So, good morning, good afternoon, and good evening to everybody who is here for this exciting conversation that we're going to have today. I'm Namrata Nadkarni. I am the founder and CEO of Intent Communications, and I'm delighted to be your moderator for today's International Chamber of Shipping leadership briefing on the application of maritime application of batteries. So most of us know that low carbon energy technologies, including batteries, are an extremely important way to get us to our goals in terms of energy efficiency and, of course, emission reduction. And of course, there is the potential to really enhance performance, particularly on short sea routes. And I'm delighted that we have a really well-informed and interesting panel today. And we have our experts who are going to guide us through the opportunities and challenges around adopting this technology. Now, before I introduce them formally, for everybody in the audience, I just want to remind you that this discussion is being recorded and it will be made available to anyone who's registered just after this meeting. So there might be a little bit of a delay, but it will be in your inboxes. It will be ready for you to look back and take away that insight that you have come to expect from ICS. And I really want to encourage you to participate. So you will be able to ask questions using the question function in your control panel. And we've received a number of questions ahead of this webinar, and we will be doing our best to answer all of them. In some cases, we've threaded them together to give you the best insight, best value. So without further ado, let's introduce my speakers. So first of all, I'm really excited to welcome John Storpert, who is the Principal Director of Marine. Welcome, John. And next, I want to introduce Jonathan Leong, who is the Principal of Business Development at the Faraday Institute, which is the UK's dedicated research institute for electrochemical energy storage. And for the rest of us who have to translate that, that is basically batteries. So if you want to know anything batteries specifically across the world, Jonathan has deep technical knowledge for sectors outside maritime as well. So welcome, John. Next, and equally warm welcome to Timu Kulakalion, who is the Head of Research and Development at the Roma Marine Constructions, which is a specialist shipbuilder based in Finland, which I know has really adopted battery technology in an interesting way. And I'm lucky enough to have been on some of the ferries that have done so. So, there's a real connection here. And completing our panel today is, of course, Katie Taylor, who is the CEO of Whitelink, which is a short sea ferry operator that provides services between the Isle of Wight and mainland UK. So welcome, Katie. So I thought, John, if we could start with you giving us a brief overview and perspective from the International Chamber to get our audience up to speed on the landscape in which we're going to be asking these questions.
Thank you, Namrata. And on behalf of the International Chamber of Shipping, it's my pleasure to welcome everyone to this webinar on the maritime application of batteries. We in the shipping industry are entering a new era of innovation and responsibility as we strive to meet ambitious decarbonisation targets and respond to growing environmental expectations. Batteries are emerging as a vital enabler of cleaner, smarter and more efficient maritime operations. From enabling zero emission operations in ports and coastal waters to hybrid propulsion systems that reduce fuel consumption, batteries are reshaping the way vessels operate. They provide operational flexibility and open new opportunities for innovation across ferries, offshore vessels and cargo ships alike. But challenges remain, from safety risks, high upfront costs to limited energy density, charging infrastructure gaps and recycling concerns. So this webinar is not only a platform to explore the technical potential and the challenges associated with marine battery solutions, but it's also a forum to discuss the regulatory, financial and operational pathways that will accelerate their adoption. By bringing together industry leaders and innovators, we hope to provide considerations on how battery technologies can become practical, scalable solutions that will help shipping meet its sustainability commitments while remaining competitive. I'm really looking forward to the discussions today. Thank you, Namrata.
Thank you so much, John. And I think, for many of us, of course, we are used to the idea of batteries around us in different things, ranging from our phones to our cars to other aspects. So I think being able to talk about the real application in maritime is going to kind of connect those worlds together. And I'm really excited to hear what our next speaker is going to say, because he's going to bring that really specific perspective. So Timu, could I turn to you now, obviously, to talk about the overview of marine electrification and your perspective as someone who retrofits vessels and is also, of course, a shipbuilder.
Yeah, good morning, good afternoon, good evening to everyone from Finland. Glad to be here, participating in this discussion. And as introduced, I've been involved, and we have been at the Rauma shipyard. We've been involved in first of all, building a hybrid vessel operating on LNG and batteries on the side to boost or to bring the efficiency up. And we have been involved in actually several research projects for going towards fully electric vessels in let's say the big scale. So talking about 200-meter long RoPax vessels, which is something that is not quite there yet, but hopefully we will see those projects coming from research projects into reality in the next few years or so. What I've learned over the past years is that batteries and the applications of batteries, talking about the different chemistries and different ways of how they can be utilized and where they are suitable in which types of operational profiles, which type of ships, routes, etc., etc. There is no single source of truth. There is no silver bullet, but there is a variety of different opportunities and different solutions, and they all, when they are utilized in the correct place, in the correct way, they all support the let's say bringing the emissions down and the efficiencies up. So it's just a matter of using them in the correct way, in the correct place, and then finding out the perfect fit for the problem at hand or challenge at hand.
Wonderful. I would even say the opportunities at hand. And I like the idea of zooming us out. So now that we have that maritime perspective, let's connect this to the overall perspective. So Jonathan, could I turn to you and invite you to give us a real look at the landscape, where the opportunities are? I know that you have a really interesting paper that I was looking through from the Faraday Institute talking about the specific applications of batteries and the types of different opportunities, including short sea, including the types of vessels, and including a look at how it can be used in a deep sea context, which is of course extremely different. So Jonathan, could you share a spotlight on that?
Yeah, sure. So thank you, Namrata, and hello everybody. Just a quick note that the contents of this slide are mostly derived from that insight that Namrata's mentioned, that was written by my colleagues, and it's been published last February, and it's an insight that I'll be referring back to throughout throughout this talk. Next slide, please. So if we just take a holistic view at the maritime industry, it is a significant sector that contributes to both the economy with regard to movement of trade, creation of value and jobs, but it's also a sector that contributes towards climate change and has a responsibility to decarbonize. And I think one of the key differences of the maritime sector, if we compare it to automotive, is the breadth of use cases and therefore the accompanying vessel types and the various applications that are present. And this range is painted in the bottom, from the left, from things like shipping, transportation of billions of tons of goods every year, and ferries, all the way to the right-hand side where you have things like leisure craft and probably more I guess prevalent in the last couple of years at least, underwater, unmanned underwater, unmanned subsurface vehicles for defense applications and potential surveying applications. All of these applications are in some capacity looking to wean themselves off hydrocarbons, and whether that's from a security supply or from operational benefits. And from our insight, the resulting market for this alternative fuel space is forecast to be tens of billions of pounds by mid-century. Next slide, please. And much like the end application within maritime, the fuel source mix is pretty broad, with a variety of trade-offs and considerations for each. And currently, it is a mono-fuel economy, heavily reliant on oil-based fuels. But that share is projected to drop significantly by mid-century to a much more mixed and multi-fuel domain. Hydrogen-derived fuels like ammonia, e-fuels, will be, I think, dominant, given the graph on the right. And for batteries, both the domestic and global level, they will factor in some capacity, but the amount they will account for is probably a bit smaller, given some of the hard limitations of electrochemical performance. I think what is also interesting from the graph on the right is that the overall energy demand for the UK is actually expected to drop as energy efficiency improves throughout the next 20 or 30 years. Next slide, please. Despite saying that, and despite, I guess, commenting on the fact that the overall share for batteries will be small for maritime, it will still be significant. And here there's various stories and snippets and articles that just signal the growing interest in demonstrators and the deployment of batteries in the maritime space in the last 6 months or so. So it is a growing area of interest, and indeed that's why everyone's on this call. Next slide, please. And whilst lithium-ion batteries continue to develop and iterate at pace, that is driven largely by the automotive sector. There are broadly 4 key challenges or themes which will impact their ongoing implementation and uptake, both within automotive and across other sectors. So the two in the middle, reducing costs and designing in full circularity, will benefit all applications. But the two themes with red boxes are really I think, of particular importance to maritime. So if we hit the top red box, performance optimization, actually being able to kind of get and utilize the maximum amount of battery is critical. So for example, actually maximizing depth of discharge, so being able to use all of the active material, it is important, and ultimately that will impact the range of the application. And currently, depth of discharge is limited mostly to minimize degradation. So if you can understand, prevent, and mitigate degradation, then you can actually extract the most of the active material and therefore reap the maximum benefits of batteries. For the second box, in the bottom, different sectors will have different use cases with different mission profiles, with different trade-offs, both at a technical and economic level. And so developing batteries that are specifically designed for these applications beyond automotive will enable them to be fit for purpose rather than be shoehorned in. Next slide, please. And so where do batteries fit within this maritime domain? Ultimately, maritime, I believe, the battery technology has the unique advantage of being able to leverage that development, that volume, those economies of scale, and ultimately investment that 15 plus years of automotive EV has done. And ultimately, it will allow the maritime market to tap into that commercialization and R&D effort. Electrification of maritime, I guess, can take multiple kind of flavors. So both within the vehicle itself and actually kind of the wider infrastructure. So if we look left to the vehicle, I think in its purest sense, it could be pure propulsion of battery, which again, Namrata mentioned very much kind of that smaller journey kind of use case. Hybrid, I think, is quite an interesting use case as well, because you have different flavors of hybrid. You've got dual propulsion, so actually turning your propellers, or actually maybe using it as part of or within different segments of a journey. So actually, your pure propulsion for when you're leaving or entering a dock, and actually the main journey over the sea or the ocean is on an engine or combustion. And then hybrid could also be actually just powering supplementary auxiliary systems as well. And I think some of the benefits that electrification can provide, of course, reduction in emissions, but actually use of batteries. Electrochemical batteries are quite an energy efficient, energy conversion efficient medium, especially with electric motors. And so the potential knock-on benefits of that with regard to things like fuel consumption in a hybrid system, as well as noise reduction as well. If we look to the right,
there's vibration reduction as well, isn't there? When your vessel is in port, if you're using that kind of power, you're not going to have that vibration, which can be useful for like cruise vessels and that sort of thing. It's super interesting.
Yeah, exactly. So it's definitely knock-on benefits as you go up the length scales, at your module level, at your vehicle level, etc. Yeah. Then on the right-hand side, with regard to I guess the local infrastructure, interesting opportunities and challenges with regard to the port and localized port. So again, going back to that mixed fuel domain in the future, that there will be mixed fuels required when you dock. I think the key one for electrification is very much having grids that can meet the demands of charging and the necessary amounts of reinforcement required, and also the fact that it may not necessarily be consistent demand. It'd be quite peaky potentially, and there's potentially high capital costs in terms of updating and reinforcing those grids to enable all that charging. And actually that can be compounded more with things like if the actual local port infrastructure, the cranes, your forklifts, the vehicles, etc., the cabins are all also electrified as well. Next slide, please. So if we take a little bit of a deep dive into batteries, I will say that we focus on these three chemistries in front of us. These three chemistries here are what are commercially available today, and the ones that are right now of interest to Maritime. So if we look on the left and middle, the two blue columns represent two different cathode chemistries, and then the yellow on the right is the anode. So if we start with that one on the right first, lithium titanate, LTO, it is an alternative anode material to graphite, which is typically what's used. LTO is interesting because it's very good at fast charge discharge and power, and also low temperature or operation as well. So when a kind of more extreme operating environment and where large bursts of power required, LTO is quite an interesting anode to use for maritime. And indeed, one application I've given is for tugboats, for example. If we look to the left, NMC, so it is one of the kind of main cathodes of choice today. NMC, nickel, manganese, cobalt, is kind of the de facto choice really for high performance automotive because of its increased capacity and energy density. And again, so therefore, applications which require a bit more range, high performance, may look to utilize NMC. And then on the left, LFP, lithium iron phosphate, it is a chemistry that has definitely taken up or had a large adoption in the last 5-10 years. Actually, originally it was considered to be too low energy density, but because of various engineering and design improvements, things like cell to pack and different cell formats, so like things like blade formats, it's enabled to have actually quite a comparable module pack energy density, and therefore it's quite common in entry level and even some medium market automotive applications. And point of this table is to kind of just show that really that there are trade-offs for every chemistry, no matter which one you pick, and therefore that there will need to be some prioritization in terms of your use case, application as well. And I've just given a kind of rough flavor of some of the potential applications which these chemistries could feed into as well. Next slide, please. So in terms of, so what batteries, opportunities and the kind of challenges for batteries, we start from the top left. I've touched upon some of these, the efficiency, the low vibration, the noise, etc. And I guess one other I should comment on is maintenance, actually, potential simplification, utilizing batteries, which can enable maintenance and repair to be potentially simplified. There are, of course, limitations. So on the top right, gravimetric energy density is what's going to impact your range. And I think volumetric energy density is also important for maritime, where space is a premium. You're having to work within a fixed design space to accommodate your power source, and so probably more important than some other applications, say BESS, for example, or grid. Interesting environmental conditions, particularly things like saltwater immersion and exposure to saltwater. And then the last one, really, safety, critical in every domain, but for maritime, interesting how you deal with safety with regard to things like maintenance and repair versus containment, and for example, where you stick batteries on a plane compared to where your powertrain and where your propellers are. I think that's very different to automotive, very different to aerospace. So different trade-offs. Now, looking ahead, bottom right, there's plenty of ongoing research and development, and a lot of this research Faraday Institution has projects on, but all of these will I think trickle down and feed into the maritime domain. And lastly, just at the bottom left, just a view that actually all of this is kind of underpinned by the kind of overall trend of decreasing battery prices, economies of scale, manufacturing improvement, better efficiencies at manufacturing. So all of that, will impact positively the battery domain and maritime domain. Next slide, please. So just to quickly touch upon a few other points, there is growing interest, both domestically and globally, on batteries for maritime. So on the left, this is one of the competitions that Innovate UK has currently, which is live. The Shore program, looking very much at clean maritime demonstrators. On the right-hand side, a future call from Horizon Europe, which is looking at next generation battery concepts, technologies, with one view at least on maritime as one of the sectors in scope. Next slide, please. So the insight where a lot of the graphs have been derived from today have come from this insight we published in February 2025, and the QR code is there for your own reference. I would also say very quickly, the Faraday Institution has other insights, and one I'll point out in particular is Insight 18, if you go on our website, which is looking at which deep dives on lots of battery cathode chemistries. So some of the ones we touched today, NMC, NFP, and plenty of others. So maybe of highly relevant to some people in the audience here today. Final slide, please. And just say thank you for your time. People who wrote the insight are the economics team. So any questions, feel free to reach out to those folk. Thank you.
Thank you so much, Jonathan. And I used to be the editor for the Institute of Marine Engineering, Science and Technology, and we've been talking about batteries for a very long time. It's always so interesting to see how it's evolving, and the fact that, obviously automotive is really driving that trend. I think as that technology evolves, one of the things Maritime is particularly suited to doing is looking at other sectors, allowing them to sort of invest and learn, and then adapting it without having to make that investment. Because obviously we want to make sure, you know, your average car, most people expect the lifespan to be much shorter than a number of ferries, a number of vessels. Your average vessel lifespan is 25 years. You can't afford to get it wrong. So really fascinating. And I think you mentioned the 2 boxes. I think the box about costs is also going to be extremely relevant to Maritime as we're refreshing the fleet. But to our audience, if you've got questions specifically, do feel free to drop them into the comments and we'll make sure that we're getting back to them for you. But first, Katie, you have an actual application, of course, a real life operations experience on the Isle of Wight, on the fleet. And could you talk to us about the challenges? Could you talk to us about the opportunities? I know for a lot of operators, the conversation often also looks at space and allocation of space for either cargo, whether this is passenger or actual cargo itself, but also the opportunities itself and making sure you've got sufficient safety, redundancy, all of this. What has your experience been? I'm really curious.
Thanks, Namrata, and thank you so much, everyone, for inviting me here today. It's worth mentioning that you talked there a little bit about other sectors that have moved into battery technology. My background's not actually maritime, it's transport more broadly, and going back sort of 10 years and even longer, I did railway and I did buses. The railway has been electrified for a long time, and obviously buses have moved quite far on that journey in the UK as well. And I remember lots of conversations about grid capacity. So it's been super interesting to now look at how that's actually going to apply in the maritime world, and actually interesting to see where we are on those journeys, because I think you're right in saying that maritime's perhaps not quite as far advanced on that journey as some of those other transport sectors. And I'm sure that sort of long life cycle of vessels is part of that challenge. And also the fact that, you know, if a bus breaks down, it broadly breaks down in your high street. Whereas obviously if a ship breaks down, then that's out at sea. So there's quite different challenges there. So I won't talk for too long, and I'm talking about my experience and it's experience of my colleagues who've come before me at Whitelink, when the decision was made to try and reduce our carbon emissions across a number of activities, and obviously primarily talking to Jonathan's point there about where the emissions come from within companies. It's actually from those vessels themselves. So next slide, please. You'll see this is who Whitelink is. So we run from the bottom of the UK to the Isle of Wight. The Isle of Wight doesn't have an airport, it doesn't have a tunnel, it doesn't have a bridge. So ferries are a lifeline service. It's also a tourist destination, particularly domestically, but obviously internationally. And we run these 3 different routes with a number of vessels that are both car ferries and a number of fast catamarans that are for passengers only. And you'll see there we do 45,000 sailings. So this is sort of a bus on water. So these are short crossings, but they run very, very regularly. So every 20 minutes on one route, we're sailing at the moment. And we do that 364 days a year. We do have Christmas off, and we're moving 4.3 million passengers. Next slide, please. One of the interesting things about Whitelink, and Jonathan touched on the difference between sort of port electrification and vessel electrification, is that at Whitelink we are an owner of both. So we own both 4 of our 6 ports and have long leases on the other 2, and we own all of our 8 vessels. So we're actually both a port authority and we are also a vessel owner. So you can see here what our overall emissions are across the fleet, and that's what we're trying to reduce over the forthcoming years. You will see the picture there at the bottom right. That is the Victoria of Wight. She is our hybrid ferry, and if you go to the next slide, I'll talk a little bit more about her. So she was introduced in 2018. The ideal would have been to go fully electric to start with, but the grid capacity wasn't available, and I'll talk a little bit about where we are on that now. She's 8,000 gross tons, so she's heavy. She's a big ship. She has a very narrow or very shallow draft because of the depth of the Solent. She is designed to fit particularly within our port infrastructure at both ends of her journey on the mainland and on the island. Through making her hybrid, so we have the diesel generators that charge the batteries, so that then we can switch to battery power when we want to. and we do that certainly when we are in port at either end. So we are zero emission while in port, and obviously have the option to run longer if those batteries are charged. She saved around 6,000 tonnes worth of carbon in those 8 years, so it has been a significant saving. So something we've been really pleased to do. And obviously the diesel generators charge those batteries and they stay at a stable generation, so they're not having to go up and down, which also helps us obviously on the efficiency of the diesel generators as well. Next slide, please. So she's been in since 2018. We are just at the point now of ordering our next RoRo, our next car passenger ferry. So we haven't needed to read tonnage since then, and obviously we've all had COVID, which let's be honest has delayed most vessel purchasing plans. So we're now at the point where we wanted to order a new one. So we've spent the last 2 or 3 years having conversations around what does that new ship look like? Is she going to be hybrid? Is she going to be fully electric? So the ideal would have been to go fully electric. However, that's proven challenging, and I'll talk a bit more to that. So what we are currently looking at is using another or designing another hybrid vessel, but will be different to Victoria. So she will have more battery power in her, so that she is able to be retrofitted at a point in the future at which we have the grid connectivity. So Victoria can't be retrofitted. She is now a hybrid for life. So she, as I said, she's been in since 2018, so she's got a good another 30 years to go. She is going to be hybrid. However, the next one we order, we want to make sure that we can retrofit to then become fully electric, and we are putting more battery power on her so that she can do more of the journey under her battery and less on those diesel generators. However, we do require this 15 watts at each end, and this comes down to the grid connectivity that we have and our calculations, I guess, around looking at different fuels and believing that electricity is the best, or electricity and battery is the best combination for us because it's a short journey. And we were having the conversation around, you know, how do you work out how much battery you need? Well, it depends on lots of things. It depends on how choppy the sea is. It depends on how much it's raining. It depends on how many people are drying their hands on the hand dryer and how many people have had coffees and all of those different things. And so we've worked through all of that and said, actually, we do believe this is doable with charging at both ends. So this is about having a fast charge. So our ships only dock for 15 minutes while they discharge and they load, and then they go again. So as I said, buses on water. So we need to have sufficient capacity, electricity and grid connectivity at each end so that they can do a fast charge and then the ship can go again. The reason for having it at both ends, because you could probably manage with it at one end, is that if something happens, so in fact, one day this week, we got asked by the Coast Guard to stop and to rescue a windsurfer. That ship ended up being out, instead of doing a 30-minute journey, she ended up being out for nearly an hour to help do that. You don't want that situation to happen and you not be able to get back into harbour and get charged. So we are having to put that connectivity at both ends so that we can charge. It's worth mentioning, we also have the other route on the western side of the island, as you saw on that graphic. And across there we have 3 ships, which are called our white class ships. Now at the moment they're normal diesel, but actually we do have an opportunity that if we wanted to, we could retrofit those and actually remove the diesel generators and put in battery power. It still requires the grid connectivity, but actually, given we've got them for another 15 years, we could actually look at whether we could do something quicker so that we can move through this journey around decarbonisation sooner. Next slide, please. So the challenges. So you know, could we do this faster? Could we do this better or differently? You'll see this is our largest port down here on so on the mainland. This is Portsmouth. I don't know if you can see, but at the back there on the right, you can see all the flats. On the left, you can see there's a big sailing building, and then there's a pub just at the back there. You know, please do come, the Jamaica Inn, very popular. But you know, we have very urban ports. You know, we are stuffed in the coast of the UK with houses and all sorts of things around us. So we have limited space. We have looked at whether we could have battery storage on our ports, but in terms of both space and in terms of the risk to residents and people around us, we've decided that just isn't a feasible option. So therefore, we are looking at grid connectivity. Our network operator is a company called SSE. In the UK, we have National Grid, who is in charge of the overall grid capacity. The reality is that they just don't have the capacity in the grid to be at a national level, and even if they did, they don't have the connections down to our ports to be able to do that. So we're having those conversations. We have a couple of options on the table. So they have a way that they can do the connections and then drip feed us additional capacity. That's a little bit dependent on again, how many people are making cups of tea elsewhere in Portsmouth, and I'm not sure that's the way that any of us want to run an essential lifeline service to the island, which is, oh, hang on a minute, can everyone just sort of stop loading and just hold on for 15 minutes while we try and get a bit more energy from the grid? So a little bit more confidence and security around some of that supply is going to be needed. It's also worth touching on the cost of some of this. So it's around £4 million for us to get the connection through our grid provider. So that would provide capacity for this route, just for this route. So it doesn't touch our other two routes. And then on top of that, we would have to do our own infrastructure costs. So obviously from the power station through to our substation through to our ships, and then all of our charging infrastructure we would also need to pay for. So this is not a cheap investment. On top of obviously the cost of a new vessel, which as many of you know, but the sort of the shape and size of our vessels is the 20 to 30 million mark. So this is quite a significant add-on if you're going to go fully electric. We do also have, you may recall, we have the fast catamaran passenger ferries. We would like to electrify those. They are slightly easier, they are slightly lighter. You could probably build them for a bit less as fully electric. The slightly different challenge we have there is getting grid capacity. We sit at one end at the end of a train station. So obviously the train station has grid capacity, but it's literally a pier at the end of the train station. At the other end on the island, we are at the end of the Europe's oldest working Victorian pier. Victorian piers aren't known for managing additional technology and infrastructure, as you can imagine. So again, just considering, and it's about, I don't know how it's about, it's over a kilometre long, this pier, before you get to the very port at the end. So again, that's not without its challenges. So just touching on a couple of other challenges, the cost of electricity at the moment, and Jonathan touched on this, it's not making it super compelling, if I'm honest. There was a point, and I remember this from my bus days, there was a point where electricity genuinely was significantly cheaper, and that made the business case stack up. So all of this CapEx investment was offset by the OpEx that you would spend on electricity versus diesel or marine gas oil that we use now. That trade-off isn't there any longer. That differential isn't great. Brackets, Iran war. I mean, that has obviously pushed up the price of all fuels at the moment. So we are having a bit of a blip there. So who knows what's going to happen there? But definitely a more compelling cost of electricity would definitely help accelerate the adoption, because you get a better business case and a quicker payback, which is what we need. And I just mentioned two other things. You talked a bit about barriers earlier. You talked about space in terms of on our vessels. It does take up a big chunk of space. I'm not sure that's been our biggest concern. Weight is probably our bigger concern. So interestingly, Victoria is and we have another ship called the St. Clair. They're the only two ships in the UK that are fully subject to the UK's rollout of the emissions trading scheme. Seems a bit ironic that our hybrid vessel would be one of the few that are caught, and part of that, not total, but part of that is due to her weight because of the batteries that she's carrying. So you go hybrid, you do what you can do to reduce emissions, and then you actually get hit by an algorithmic way of working out who pays emissions, and it's based on the weight of the ship, and obviously batteries are significantly heavier than just the diesel generation and the fuel. So emissions trading scheme is starting 1st July, so less than a month, and that's costing us about an extra £1 million a year. So we have lobbied extremely hard across the UK to try and have an exemption for this, as they do in the EU. The EU has the small island derogation, which would apply perfectly to the Isle of Wight. The population is about 130,000. It doesn't have full hospital facilities. It is a lifeline service. It would work really well. However, the government has chosen not to award us that derogation. So the idea of the additional cost of infrastructure to get the grid connectivity at the same time as you're paying a tax to the government, which is essentially a green levy, is a bit challenging to stomach. We have asked if it's possible to put that tax into the grid connection. So, you know, we're paying £1 million a year. If you put that £1 million into accelerated grid connectivity to the ports, happy days. We would happily pay that tomorrow. We would not grumble. But to have that money going straight into the central government and no additional investment coming down in order to help us to electrify, which is what we want to do because we want to reduce our carbon emissions, feels like a fairly perverse incentive to do something. And I'll just finish the last slide a little bit about some of the other things that we're doing around reducing carbon and just trying to reduce our impact on the environment. So we have done a huge amount. So as you can see, since 2007, 35% reduction in emissions. We've installed electric vehicle charging. All of our own vehicles are electric. We've put a huge amount of solar panels across both our, we're putting them into our car parks, but we've put them across all of our ports and done a huge amount around food waste and local food, so those sort of food miles, and we've even invested in seagrass and all sorts of sort of biodiverse things. Interestingly, that there's a biosphere on the Isle of Wight, so you know, it's a real protected marine environment, and we absolutely take our part in keeping that environment as clean, as protected for the future as we possibly can. Namrata, back to you.
Thank you so much, Katie. And I appreciate the complexity that goes around all of this, right? Because any journey towards a goal, which is aspirational, which is, you know, protecting the environment, making sure that we are as green as we can be, the metrics for as can be are going to keep moving, and rightly so, right? We all benefit from it. But that teething is so challenging. And I think it's really interesting, the points you brought up. I was also, by the way, extremely impressed that you've talked about refueling and the electricity at the port and making sure that you refuel humans in the pub right there. So well done you for planning that out.
Always.
But Timu, if I could come to you, because obviously, as Katie pointed out, there are some really significant challenges, and the weight of the batteries is one of them, right? It's for deep sea, obviously you're looking at size, you're looking at weight, you're looking at those implications. What are the kinds of conversations that are being had with you as a yard, as that retrofits to look at that? And is there anything else you would like to add now that you've heard what everyone else has said?
Yeah, thanks. It was nice to hear from Whitelink that you actually have the capability to make decisions for both the ship and the port, which is not often the case, and that's actually one of the main hurdles that we've identified over the past few years, that it's enough to have the ship owner who wants the fully electric ship, because the port side needs to make also heavy investments in the range of millions or even tens of millions when going to the bigger ships, and they have very long lead times to get the high power connections to the port and so on. So in a way, I like that you have a good position to make decisions on your own, even if they may be costly and economically need a bit of work still. Coming to the weight issue, yes, batteries are a bit heavy, depending of course on how much and what chemistry you want to apply, and every ship is different how much space and weight reserve there is. But we have seen some examples of actually sacrificing something from on board. Let's say the Aurora Botnia, for example, that operates between Finland and Sweden, and nowadays having 12 megawatt hours of batteries. They just installed, half a year ago, they installed 10 megawatt hours of batteries, sacrificing one of their freshwater tanks and converting that into an additional battery room. So they had 2 megawatt hours originally and upgraded now to 12. So there are potential, or there are opportunities to sacrifice something when it makes sense. And actually, I was just on board there this Tuesday and asked if the sacrifice has meant something for their operations, and the captain said that not really. They have a little less fresh water on board, but they are anyway bunkering water every day. So no, operationally no change, but now they are running on much more electricity and much less fossil fuels or actually bio LNG that they are running. But anyway.
That's really interesting, and thank you. And I think, you know, obviously we've had a wonderful discussion. I'm about to start pulling some further directed answers out of our panelists, but if anyone in the audience has questions, we're going to spend the rest of this webinar answering them, so please just pop them through. But we have already received some questions during the course of this conversation and in advance. So perhaps we could talk about, you know, the carbon intensity and kind of carbon capture and the green impact for vessels that are being retrofitted. So for older ships, I know, you know, we've talked about different types of chemistry. We've talked about the evolution of batteries and the fact that, you know, Jonathan, you pointed out that there's going to be a lot of progress being made driven by the automotive industry. Does anyone want to talk about the real impact that it could have on older vessels that perhaps, you know, if we're looking at it more than 15 years old, right, where they've got that, you're kind of in the waning stage, moving towards vessel recycling. How would this be impacted? Can batteries really make a difference? Is it worth investing at that point? Or do you think it's far more skewed because of the money required and because of obviously the infrastructure required for new builds far more, or younger ships? Timu, perhaps I could go to you first, and then to anybody else on the panel to allow you to prepare your answers.
Yeah, again, highly depends on the case. Does it make sense or not? What is the, I mean, what's the power or propulsion configuration? But for example, if taking an LNG powered vessel operating in the EU waters and now under the FuelEU Maritime regulations, adding or retrofitting even a fairly small battery to optimize the running profile of the gas-powered engines and reducing methane slip with that can make a lot of sense and actually bring down the emissions and the operational cost. So, for example, the Aurora Botnia that I just mentioned, they are now running only with one. They have 4 engines on board, and they are basically almost all the time running with one engine. And when the engine is running, it's running at the 90% load on the sweet spot, maximum performance and minimum methane slip. So it makes a lot of sense. But then depending on what is your fuel and what is your power line propulsion configuration, it may not make sense.
It's absolutely a dance. It's an equation, isn't it?
Yeah.
And I think, Jonathan, when you had been illustrating the points, we had obviously, you know, when most people are talking about battery-operated ships, purely electric, purely battery is a really small niche of maritime, of the global fleet. But for larger vessels, and we have some questions coming in about specific vessel types, so bulk carriers, containers, that sort of thing. My understanding is the application is far more to kind of do the spikes in power usage. So your engine itself could basically operate within a fixed band, and anything which suddenly requires that, such as, you know, larger waves or something that is not expected to be a long-term operating condition, the battery could do that, so you don't then have to vary loads and have that fuel consumption really move all around. Do you think that over the next few years that's going to start really justifying return on investment?
Wow, good question. So I think if that use case you gave, I think if that was from a retrofit, I'd say probably not. You know, I don't think it'd be the most efficient way of utilizing batteries, in my opinion. Just as a complete aside, I've got a comparable example from the aerospace industry, where in a similar vein, they, you know, will potentially look to use hybridized systems, you know, use gas turbine combined with batteries or capacitors or whatever else. And actually, the kind of real benefit in a similar vein, that kind of to reduce some of the power spikes, the peakiness, for example, when takeoff and landing or during an aborted landing, you know, the benefit for that is then it allows you to potentially downsize your gas turbine. So really, I think the benefit is baked in at the start of life, not kind of as a retrofit, for example. So somewhat dependent, but yeah, I think in a short-term case, probably not. If you're starting from a clean sheet, brand new design, definitely, potentially.
No, that makes sense. It's almost a shift in how you're thinking of it as primary propulsion versus the redundancy system, cool. Right? And that's the kind of investment you need to then look at. But Katie, can we come to you to talk about this? Because obviously you are the person into whose pockets the investment is coming out of, right? So you're looking at this investment, you're balancing the justification of what you're doing. And I thought you illustrated that really beautifully when you said, for the vessel from 2018, we decided we couldn't. For the vessel that we're looking to commission, we've really been thinking about leaving space. How much, would the evolving chemistry composition be playing a large interest in that? I assume that you're paying really, really close attention to how you can get more power out of smaller and lighter batteries. And could you also a little bit talk about, because I think this is really relevant, the fire risks? Because we know in maritime, we talk a lot about onboard fires, and with lithium-ion batteries, particularly for ro-ro ships and RoPax ships, that's a real concern.
Yeah, sure. So I think the retrofitting is the cost challenge for sure. That is your challenge, which is, it is not cheap to retrofit, and therefore, are you really getting the value? And actually, your propulsion system is often a significant part of your cost of a ship. That and your hull are your two big costs. So you're sort of trading off the two of them. So I think it's something we are considering for, as I said to you, these three vessels that we've got. But the economics really have to stack up, and so we're still looking at it for that one. The point about fire risk, actually, we had a huge amount built in terms of safety and security, I guess, when we had Victoria built. So we have huge fire compartmentalization. Those big doors that you have to sort of step through. We've also got a very sophisticated fire suppression system, blanket, the showering. We have all of that. And we also, there were a couple of other bits, but one of my colleagues was just telling me that there's extra things that we do. We've got a battery management system that manages it. It's tracking that temperature all the time, so we can monitor. So if we ever see the temperature going up, we can go and we can have a look. So we've got a huge amount of wraparound, and we've never had a problem or a concern. So I think it's fair to say, whilst I know there have been challenges across shipping around carrying electric cars, actually the carrying of the batteries installed in the ship has never been a challenge.
And I think it's really interesting because you're talking effectively about condition monitoring at like real scale, and the lessons that you will have learnt from this on your short routing would then feed the creation of these kind of monitoring safety mechanisms for much larger vessels. I think that's really fascinating, and I hope that we can look forward to you sharing the learning soon, because I'm sure our audience would be very, very interested.
Sure, and we've got a supplier, so we have Corvus who supplies our batteries. So I imagine they will supply other batteries with for other ships. So they will be gathering that data, and that data is available. Yeah, very happy to share anything with the.
I was about to say, I know for a fact that Jonathan would be interested in any of the data that anyone who's looking at batteries would be willing to share, obviously. But right, so let's kind of look at this from the other side, and let's look at what we should be doing in terms of the shore, of course, and making sure that those hookups are there. We've got regulations that are requiring shores to requiring ports, to electrify and to offer this. And there are now, understandably, large conversations about sort of energy security happening at national levels all across the world. Do we feel, Katie and Timu, that there are sufficient conversations happening almost between the ports and the vessels to ensure that there is alignment? Because, as you said, Katie, if someone's making a cup of tea and you can't charge a ferry, that's a real operational issue.
Yeah, so I guess So I go back to when I worked in buses and trains. At the time, we were having conversations where we said, look, if all of this stuff happens, we haven't got sufficient capacity in the network. We knew that 10 years ago. And I think it's taken a long time for the government to really realise that, because, you can't always look ahead when you're dealing with challenges in the moment. So they are now starting to look at where they're going to get that extra capacity from. So I think we're on a journey recognising that the additional capacity that we need at ports. So it's on its way. It's probably just taking longer than perhaps some of the other technologies have come about, and actually we could go faster on the technology and on the ships than we're able to go in terms of the port capacity. So I think that's probably where we are today. I think the resilience of the network's not bad, actually. I mean, it has been patchy over a number of years, but I think there is a lot more investment, certainly in the UK, in making sure that that network is resilient, because you can't have outages and you can't be having those dependencies. So I do think that's part of where the government is going on this. I just think it's going to take, so, you know, we would like to order a ship today, ideally, that is electric, but we would need guaranteed capacity in port for 2029 in order to do that. There will not be. We're talking 2033 to 2037 is when we're going to get that capacity. So I guess we're running 10 years ahead of where the grid capacity on the port is. And I guess to Timu's point, at least we're in charge of that, which I think is a positive. I have my moments. When you own a Victorian pier, you know, sometimes you wish that someone else did own it.
You're guaranteed market demand if you're in charge of it, right? As opposed to the other way around, where you have to do the field of dreams, build it, and maybe they will come.
Yes, there are positives, but it's also hugely expensive we have to maintain all our own port infrastructure, and I mean that the costs of that are not quite the same as vessel maintenance costs, but it's not far off. So it's just, you know, it's an additional cost, and there has been probably more investment in some of the big port operators. And so you have seen some extra grid capacity coming to sort of AB ports and some of those other big ports that perhaps, because we are those smaller bespoke ports, we haven't necessarily got. And I think there's a point about it. It largely depends on individual countries and how they are set up to recognise strategic assets versus general assets. And historically, the UK has basically recognised a port. And I mean, we've actually clubbed together locally with the university and a very large shopping centre and said, look, all of us need more grid capacity, and a football team, actually, all of us need more grid capacity.
Yeah.
We can't be competing with a small housing development over there or a farm that just wants to run its machinery a bit differently. And historically, it's been set up that we would compete with those things. It can't be like that. You've got to see what your strategic industries are and how you support them.
Understood. So I know that I could definitely continue to talk about batteries for quite a long time, but unfortunately, I'm a good moderator, and I know that we have to stick to timings. But I'm sure that we can continue this conversation online, on social media, or with emails to our wonderful moderators. So moderators, that's me, our wonderful panelists. But I thought it would be useful to just do a really quick wrap up with our panelists to say, if you could talk to our audience and you could talk to people and you would say you would like to give them something to think about, what would you like to do? And Jonathan, could we start with you? What would you like our sector, maritime as a whole, Monolith, to think about?
So coming from a battery and in particular battery research perspective, I would say, you know, ultimately battery invention, improvement, iteration is such a fast and dynamic field. You know, chemistry's concepts, ideas that weren't viable, didn't exist 5-10 years ago, are now literally, you know, ubiquitous in certain products. And, you know, for the maritime domain, you've got a quite unique opportunity to be, you know, an intelligent customer, be a fast follower, and you know, that opportunity allows you to leverage and ultimately cherry pick the best bits that you need for your own use cases and appliances.
Fantastic. And I know we didn't get time to even talk about disposal, but I assume the Faraday Institute has some material that anybody on this webinar can have a look at. So I really encourage you to do that. Timu, could we come to you? What do you want the maritime sector to think about?
I would summarize it as huge potential, huge opportunities, but do your research thoroughly, think of all the different options available and make the right decisions. And that's the way to go.
I mean, that is literally a soundbite. It's research, and make sure you get it right. I mean, I hope we all listen to that. Katie, what would you like us to think about? I feel like I've given us a bit, so yeah.
No, that's fine. So I guess it's about the infrastructure. It's the infrastructure to be able to support, you know, that decarbonisation and the choices you're making on vessels. And I would say for me, it's the economics of the infrastructure. Actually, is the economics aren't quite compelling enough at the moment. And the reality is that this is one of 10 things I'm dealing with. You know, electrifying my ships is not necessarily my most immediate urgent problem. I have a whole number of other challenges around finances, around staff, around you know, other things. Actually, I need this one to stack up economically. So that's really what I need. I need electricity and batteries to be more compelling.
Fantastic. So I'm always curious about what our hosts think. So John, if we could pull you in for the ICS perspective.
Thank you, and I'll be brief, noting that we're up against time. I found that absolutely fascinating. I think it was important to hear the challenges that first movers who want to invest in this technology face, and just how broad they are and how well-intentioned things can actually be counterproductive in the context of regulation and things like that. But equally, I think we've seen clearly the opportunities that this technology can present in a variety of situations, and the potential operational impacts. We've been talking about this in terms of emissions, but I wonder what the knock-on effects could be in other areas such as underwater radiated noise, and I'd be keen to have that conversation. Similarly, it'd be interesting to know how this will combine with other technologies that we're exploring in this webinar series. So it's, I think, opened up more questions for me than it's answered, but this has been absolutely fascinating. I'm very, very grateful to the panel.
Yes, and so it's just up to me to make sure that I'm rounding out what we've heard today. We've basically heard that battery technology is evolving. There are really specific use cases which apply, and if you can line up your vessel, your technology, the infrastructure on shore, and of course the pricing to make this viable, whether the pricing is for electricity or the actual technology or the physical retrofitting and the training required, there is quite a lot of opportunity. I know that there's a lot of information about how electricity and of course batteries stack up against other fuels in the International Chamber of Shipping's ICS Maritime Barometer, which will be coming out later this month. So there's information in there to anybody listening. But I just also wanted to thank all our speakers. Thank you so much. It was a wonderful presentation, and I know I've left with a lot of food for thought, and I hope that the audience has as well. Before we close, I just really wanted to remind you that the next edition in the Leadership Insights live webinar series is going to be on efficient and quiet technologies. So John, to your point about underwater noise and other stuff, that will be held on Friday, the 3rd of July at noon UK time. So thank you to everybody who shared their insights with us. Thank you to the audience who joined us. Thank you to all of you who shared your questions. I hope we've answered as many of them as we could. I know there are a few that we didn't get to. Please make sure you drop the ICS either an email or talk to them on social media, and we will try and get you those insights. Thank you very much for taking the time to join us today.